Hi GOR, this is Unit 2, Lesson 8. It's the last lesson. It's a nice short one. We're just going to do three quick problems, basically tying together everything that we've done in the chapter. And then we're going to start our review sheet. So exercise 1, I have a figure to the right shows a series of rigid motions performed on triangle ABC, which is this one all the way on the right. I did something that it became this triangle here in the middle, and then finally it became this dotted one off on the side. So I have to identify the rigid motions. How did I get from triangle 1 to triangle 2? It looks like you might have reflected it, but you actually rotated this all the way around. So I did a rotation about point C, and if I was to take out a protractor and measure that, remember, all my rotations go counterclockwise. That would be a rotation of 270 degrees. And then how did I get to this, from this triangle right here to this triangle? I did a translation. You basically translated it up and to the left a little bit. And you're going to use that vector to show the direction and the length of that translation. So I translated it from B prime, B double prime. They want me to label vertex A prime. So basically, this was my A right here. And remember, I rotated that all the way around so that this was my A. And now this would be my A double prime all the way up there. Is triangle A double prime, B double prime, C double prime congruent to triangle ABC? Well, remember, to be congruent, there just has to be a rigid motion or rigid motions that maps one onto the other. Well, I did a rotation and a translation. Are those both rigid motions? Yes. So I need to justify my answer. Yes, the triangles are congruent. Why? There is a series of rigid motions that maps one onto the other. So there's a series of rigid motions that maps one triangle onto another. All the angles and sides maintain their size. The length and angle measure are preserved. Okay. 2, give a sequence of transformations that would map right triangle MNQ to right triangle WXY. Okay, so I want to know what would map one triangle onto the other. Now you can see that this right here is a right angle, and angle W is a right angle. So I know which ones are mapping up. I also know which ones are mapping up because M is the first letter and W is the first letter. Now I want to be as specific as I can. The first thing that's easiest to do, especially when it's not on a graph, is to actually get these to touch each other. Okay, so I want to do a translation that's going to map N onto X. So I want to do a translation, and I'm more going to just describe this. A translation that maps N to X. Now, if I was to do that, N would now be down here. My Q would be sort of like right about here. I'm just going to sort of draw this. And my M prime would be down here, where my right angle is. So basically, I'm just shifting this triangle down so that I'm finally touching on a point. Now, after you touch on a point, I want to rotate it so I have a whole side touching, and then once a side is touching, then I can reflect it. So after I do that translation, so I get them to touch, I'm going to do a rotation about point X until M prime maps to W. That says 2W. So basically, I'm going to rotate this all the way around so that my triangle is now going to be here touching. Okay, so all the way around. This is going to be my Q. This is my M is now going to be touching over here, and my N is going to be touching. So because once I have a side touching, then all I have to do is reflect it over that side. Then I'm going to do a reflection over XW. So I was trying to be as specific as I can, but I'm also just writing it out sort of as it's occurring using sentences. So first you want to translate it so that a point touches another point. Then you want to rotate it so a side touches another side. And then finally you can do that reflection. And once I reflect it, I would be right here. All right. And last one. In the diagram, BAC is congruent to EDF. Describe a sequence of two transformations that would map BAC onto EDF. Be as specific as possible with your terminology. So again, there's more than one way that you can do this, but you want to get them so that they are touching. So look how B is the first letter and E is the first letter. So I'm going to do a translation. B maps to E, just so you can see what that looks like. So basically B is going to map all the way to E. So if I was to do that, this triangle would now be up here. Okay, B is touching E, but everything else would sort of be in the same position. So I might be off the page a little bit here. So I got A prime, C prime, and this would now be B prime. So the triangle's up here, but so everything's in the same position, just shift it up. Now after I do that, I would want to rotate it, okay? Rotation about E, because E is where they're touching. That maps angle A prime to D, side A prime B prime to D E prime, and A prime C prime to DF. So this one actually, if I just rotated it so that this whole side here, and I'll highlight it, maps onto this side. So I'm going to rotate this so that this side maps onto this side. This side here maps onto this side. And that angle A right here maps onto angle D. Then you'd be all set and it would be in the exact spot. Okay, so this one, the rotation was the final thing because you rotated into that spot. You did not have to reflect it.